So the new thing that we need to talk about today is inverse trig functions. Eventually, this will enable us to find missing angles. But first, I just need to introduce you to the concept. Okay, so I'm just going to skip to this right here. Let's set up the sine function given this triangle off to the right. So we remember that sine is opposite over hypotenuse. Okay, so maybe I should label this stuff before I get too carried away. This is the hypotenuse. It is across from the 90-degree angle. When I start talking about opposite and adjacent, I need to circle the angle that I'm dealing with. Hold on, I feel like some mute. I need to do a little mute action here. Okay. You circle the angle and draw an arrow. That's going to be pointing at the opposite side. So this is opposite. That means the 6 must be adjacent. All right. Just to help me not have to go back to my notes over and over again, I'm just going to write down SOHCAHTOA to remind us how it goes, to remind us of the definitions. Okay, so remember SOHCAHTOA, SOHCAHTOA. So for the sine function, it is opposite over hypotenuse. So that'll be 8 over 10. So we would write the sine of 53 is equal to 8 over 10. The cosine of 53 is adjacent over hypotenuse. That would be 6 over 10. All right, and then the tangent of 53 would be opposite over adjacent. So that's going to be 8 over 6. All right, that's what we learned yesterday, or the day before yesterday. So now here's this new concept called the inverse. This sign with a little -1 on it is called inverse sine. So we have inverse sine, inverse cosine, and inverse tangent. And the way it works is, if you've got the inverse sine, these two values will be reversed. So the inverse sine of 8 over 10 will equal 53. All right, you just reverse these numbers. The inverse cosine of 6 over 10 will equal 53. And the inverse tangent of 8 over 6 will equal 53. So if we did not know the angle, we could use the inverse sine, the inverse cosine, or the inverse tangent to find the missing angle. Okay, that's what this is for. Okay, so here's an example. We want to find the measure of angle D. So for the first time, we are going to put the variable inside the triangle. So angle D is right here. So let's go ahead and put an X inside the triangle because it represents the angle. All right, let's go ahead and label all of the sides like we do. So this is the hypotenuse. Always start with the hypotenuse. It's across from the 90-degree angle. When we're dealing with the other two sides, we need to circle the angle that we are dealing with. Okay, in the past, we were given the angle like this 53. But this time, it's the angle that we're looking for. But this is still what we're going to circle. You circle the angle that you're looking for. And draw an arrow going away from it. And that arrow, as always, is pointing at the opposite side. That means the other side must be the adjacent side. Okay, so think about your SOHCAHTOA. Okay, SOHCAHTOA. This will help you decide which trig function we're going to use. Are we going to use sine? Will we use cosine? Or will we use tangent? And the way you will decide is by looking at the sides that you're dealing with. Notice we have the 4 and we have the 10. So those are the two sides that we're given. This is adjacent and hypotenuse. So which of these three trig functions involves adjacent and hypotenuse? Well, that is the cosine function. All right, the cosine function is the only one that has adjacent and hypotenuse with it. So that's the one that we're going to use. So that's why we know to start off with cosine. You know how normally we would write the angle now, right? We'd have the cosine of 53 degrees, but we don't know the angle. The angle is x, so that's okay. We're going to put the cosine of x. And cosine is adjacent over hypotenuse. So that's going to be 4 over 10. So I've got my 4 over 10. Now, here's the key that we just practiced above. We could use the inverse cosine to solve this. Okay, if I do the inverse cosine, so I'm going to put a little -1 here. Now, let's do what we did up here. Remember, when you do the inverse trig function, all you do is you reverse these values. All right, these are just going to get reversed. So if I want to do the inverse cosine, that means the x and the 4 over 10 are going to trade places. So the inverse cosine of 4 over 10 is going to equal x. So that is a clever way of getting x by itself. This is how we can solve for an angle. Okay, let's go ahead and put this in our calculator. So it's just going to take me 1 second to turn on my calculator. All right, everybody have your calculator out. Hopefully you've got a TI-30 XS multi-view like me. Okay, so on your calculator, you see the cosine button, but above that it says cosine with a little -1. Well, guess what? That is inverse cosine. So we want to do the inverse cosine of 4 over 10. So we're going to do second. To get to the stuff above the button, you have to hit the second button first. So I hit second cosine. So that's inverse cosine. And now I do 4 over 10. Inverse cosine of 4 over 10. Bam! That gives me 66.422. Don't forget we're doing 3 decimal places, and you have to round up in this case because the next number is an 8. So 66.422. 6.422 degrees. So that is the value, the measure of angle D. Okay, so this is a new situation. If you look back to yesterday's classwork, we decided we had these two situations. When the variable is in the top, you multiply. When the variable is in the bottom, you swap. Now, this is the third and final situation. When the variable is inside the trig function, you do the inverse. So go ahead and write down inverse really big right here. All right, this is the third and final situation. Okay, so real quick, looking at this first picture, first we have to decide. So this is the hypotenuse. Okay, and for the other two, I'm going to circle the 25. Boom, that makes this opposite, and this is adjacent. Okay, now these pictures are all kind of the same. So this is hypotenuse, this is opposite, this is adjacent. Okay, this is hypotenuse, this is opposite, this is adjacent. So that's always the first step. So let's set up an equation. Because we're looking at the 14 and the x, that's opposite and hypotenuse. Opposite and hypotenuse. I should write down SOHCAHTOA, shouldn't I? Okay, SOHCAHTOA. All right, so opposite and hypotenuse, that is the sine function. So that tells me to write down sine of the angle is equal to opposite over hypotenuse, x over 14. Okay, so that's the setup for that problem. All right, let's set this one up. All right, again, in the back of your mind, SOHCAHTOA, SOHCAHTOA. For this problem, we've got the x and the 17. That's opposite and hypotenuse is still the sine function. So I'm still going to do sine. The angle is 28. I've got opposite over hypotenuse. That's 17 over x. Okay, so that's how you set that one up. And then last one, okay, SOHCAHTOA. Look at the two sides you're dealing with, 40 and 21. That's opposite and hypotenuse. Still the sine function. So I'm going to write sine, but this time the angle is x. So I write sine x equals. And then opposite over hypotenuse. So that's 21 over 40. So these are the three different situations. For the first problem, the variable is in the numerator. All right, I'm just going to shorten that and say that the variable is in the top. And we have learned that when the variable is in the top, that is when you multiply. Okay, all right, on the second situation, look where the variable is. The variable is on the bottom. And we learned yesterday that when the variable is on the bottom, that is when you swap. Okay, the variable is on the top, you multiply. Now, compare that to the last problem. The variable is inside the trig function. Okay, the variable is inside the function. So this is the new one. And whenever this happens, this is when we will use the inverse. Okay, so very briefly reviewing each one of those. When I say multiply, I mean multiply both sides by 14. Okay, so if you multiply by 14, these cancel each other out. So in your calculator, you could just put 14 sine 25. Okay, so the answer would be x equals 5.9 0.217. All right, that's what we mean by multiply. When we say swap, swap means we're going to take the x and the sine 28, and we're going to trade places with them. Okay, so that's going to give us x equals 17 over sine 28. All right, that is what we mean by swap. So 17 over sine 28. So that's 36.211. Okay, variable in the bottom, that's how you handle it. And now this is the third and final situation. When the variable is inside the trig function, that's when you do the inverse. So we have to go, we started with the sine function, so we will turn it into the inverse sine. And then these sort of switch places. So we will have the inverse sine of 21 over 40. And that will equal x. And this is something you can put in your calculator as well. So if we do the inverse sine, so we had its second sine of 21 over 40, then that will give us the angle. So we have 31.668.